Good morning, everyone. I hope everyone can hear me. Probably not so good that everyone can see me. That's okay, but I want to welcome everyone to our third installment of the BC Poultry and Symposium, but also to wish everyone also a happy new year. I know it's been a trying time, but we're looking forward to brighter skies ahead. Um, I'd like to it's with great pleasure. I'd like to introduce Jess McCoy. Jesse has been up in British Columbia, and from what I gather, he likes it here. And from the feedback that we had from participants at our previous poultry symposium, they really liked Jesse as well. And Jesse has agreed to come on and continue to focus and shine a bright light on how important drinking water is for commercial poultry production. So Jesse is offered to introduce himself and also offered to handle the questions at the end of the presentation. And one final note, Jesse's agreed and Neogen has agreed to allow his presentation to be recorded, and it will be available at a later time. So without any further ado, Jesse, the stage is yours, and I thank you.
Thank you, Dr. Ritchie. I'm going to start sharing and let's get started. So today, first off, thank you for having me. I really wish I could have been there in person. I know after the last time I was there, it was amazing to visit your part of the world. It's gorgeous. I love it there. I can't wait until I can get back, and I know we're all kind of looking forward to that. So thank you for having me on. Today we're going to talk about water quality as it relates to poultry. But before that, there's a couple questions that I like to just go ahead and throw out there for you, especially since I can't see you and I find these to be odd. Stu and I have talked. I'm very much an in-person person. And so I like to start out with probably what's going through your mind is who's this guy? I used to look like that. I've lost more hair since that picture was taken, which is why I get to wear the hat. And then the other question is, am I going to run long? Right? I'm a little bit ahead of you. I'm on the East Coast, and so we're past lunch here. But I know in the poultry industry, we take lunch when we can get it. And so, am I going to run long? And my answer is no. I am doing everything I can right now to talk slow. Um, I have a Southern American accent, and I, in general, speak quickly. I'm trying not to. I would apologize for those things, but I'm too late in life to change either of them. So if you'll give me the next three slides, I can't see you. Check Facebook or Instagram or Twitter or text amongst yourselves, right? Whatever you want to do. Um, I'm really not joking about that. In person, people kind of get a little squeamish about me seeing them in the audience do something different. I'm a self-professed water geek. Okay. I know that you're probably not. If you were, we would probably know each other ahead of time. And so if you have questions, please ask them. That's really the intent of this presentation, is to have you ask questions and get to the root of what you're thinking about. If you don't, I'm going to tell you right now, I will finish early. Like I said, I'm going to do my best to talk slow. I probably won't be successful for the entire presentation. A little bit about me, though. I grew up in the Shenandoah Valley, which is in Virginia on the East Coast of the United States. The picture that you see here is genuinely from my parents' front porch. And if you look in the right corner of that picture, you will see the chicken houses that are across the creek from where I grew up. There are 9 more that continue to the right of the 3 barns that you can see there. So I grew up literally in the middle of the poultry industry. Our house was about 2.5 miles as the crow flies from a rendering plant. And depending on the wind direction, we smelled the poultry industry most days as well. So I swore I would never work in the poultry industry. And growing up in the middle of the poultry industry, though, there was nothing else for me to do. So at 16, I officially started working in the poultry industry, working in engineering and regulatory and wastewater for who is now the largest integrator in the world. But I left there and I focused on disease control strategies for all different species of animals, because what I found is that typically water going into birds smells better than the water at the processing plant. And I dealt with enough rendering plant smells in my childhood. I didn't need any more. So that's what I do now, is focus on that. If you saw the first slide, you'll see I have letters after my name. I'm a CWS, which is a certified water specialist. It's a fancy way of saying that I have studied and taken certification testing to be able to tell you what I'm going to tell you now. So the first thing I always like to start with is, why should you care about this, right? So eggs are 74% water. Birds are 66 on average. There's a little bit of difference between light meat and dark meat when you get them into the package. And manure is typically 30% water. Why do we care about that, right? Well, all of that water comes out of the drinker. They get a little bit from respiration, and yes, they get a little bit from feed, but by and large, all of the water going to your birds comes out of the drinker line. And it is the largest oral input those birds will have for their entire life. They're typically going to drink twice as much, and it's actually a little bit less than that, but we like to say birds are going to drink twice as much water as they eat for feed by weight. And so in the life of a typical broiler, I like to think of that as about 2.2 gallons of water throughout the life of that bird. And it's a key nutritional and biosecurity component of production, right? What does that mean? Well, that means over half of your end product is water. And since I am a believer in saying the things that are important more than once, I'm going to say it again. Over half of your end product is water, whether you're a hatchery, whether you're a broiler, whether you're a layer, whether you're doing pullets, whatever you're doing, whether you're processing birds, over half of the product you sell is water. And what that means is that over half of your pay is water. So what you sell to a customer, whether that customer is a different poultry grower, whether that customer is somebody at the retail store, over half of that money that has put the computer in front of you, has put the shoes on your feet, the gas in your truck, the clothes on your back, over half of that money has come from water. And so, in my opinion, you should be looking at water extremely close, right? Because it's paying you more than anything else. If you are bored at this point, feel free to tune out. If you want to talk more about how water affects your income level, then please pay attention. That's what we're going to talk about. So today in Zoom University, which was established in 2020, we're going to talk about which parameters in water affect poultry production and how to figure those out. How those parameters affect poultry production, how to identify those, kind of the high level remedies to the issues we find in water. We're not going to get to the granular level on that. And then we're going to do questions and answers. My intent today is to give you half the information. And I hope that you ask for the other half of the information that you're interested in. And the reason I'm going to do that is because water is brutally boring, especially when we talk about chemistry. And this is coming from someone that actually enjoys talking about it. And so what I'm trying to do is to give you highlights that then spark interest and questions from you. So I've left a lot of time at the end of this presentation to talk through the questions that you may have and those things that are interesting to you. So with that kind of agreement going forward, if you will, if I tell you part of it and you ask what you're interested in, we'll have a great presentation and we'll go forward from here. So what is good water, right? This is half of the picture that would fit on the slide with the different brands of water that are out there. And they're all a little bit different and everybody has their brand that they like. I like the cheapest one that I can find at a store, but other people like my wife swear by different brands, but all of them boil down to clean water. And so for birds, the industry has accepted that good water is free of bacteria, that it has a slightly acidic pH, and so that means a pH less than 7. There are few suspended or dissolved solids. There are few heavy metals. And why do I say few instead of a number? Because they cost money to take out, right? And so that number is going to be determined by you and what you're trying to accomplish. We're going to talk about, do nitrates matter? Do sulfates matter? I'm going to, give you a little preview. My theory on those is different than most people. But what I want to remember this whole time as we talk through water quality is these are birds. They're not people. While we treat them like our children, they're not our children. They are our business. And so they have to pay us back. We have to make money. Sustainability is a term that gets thrown around a lot in our industry and in our world now. And to me, sustainability is operating a business through more than one generation. And so as we look at sustainability for this, it's going to be about how do we keep you profitable so that that business continues to run. So these are the parameters that we care about. Okay, we care about biology. Those are pathogens that cause disease, right? We care about the minerals that can hinder performance, and we care about pH. You will notice I've put 3 things on the screen. Could I have put 15? Absolutely. Do 12 of those 15 matter to poultry production? Not in my opinion, not in a way that is practical. So what I want to talk about today are the 3 largest parameters in water that you can actually do something about and you can actually have a return on investment on. So why do we care about biology, right? This thing on the left side of your screen is a measurement device to measure biology in water and on surfaces, okay? The reason we care is that if we keep pathogens out of that bird, number one, you don't have pathogen to host contact, right? So we don't get clinical or subclinical disease, which means we can reduce medication. So we reduce the cost of raising that animal to you. Or if you're organic or no antibiotics ever, we can make sure that that animal lives the best life it can and that we give it the most humane treatment we can. Not running that immune system also helps improve feed conversion. You're going to hear me say that a couple times today. What I mean by that is that a bird has a set number of calories that it brings in, which means there's a set amount of energy that it can use. If it does not need to use that energy on its immune system, then it can use that energy to build muscle. It can use that energy to get better, and you sell animals or eggs or whatever based on weight typically. We get higher grading at a plant, right? We talk about IP at plants, right? And we talk about grading and how that changes the cost of that chicken to the consumer, and in turn changes the payment you get. So if we can keep those pathogens out, we can get higher grading at a plant. We get that reduced morbidity. We get that reduction of interaction with soluble medications. But what's really important to me about biology is what type of biology we care about. And I'm going to call that a pathogen of interest. In the food safety world, we call those pathogens of consequence. Okay. So that's going to help us choose exactly what we need to do with your water to help improve it for that animal. What pathogens of interest, right? You see there's what, 10, 12 different pathogens I've got on the screen right now. I have personally found every pathogen on this list in a water sample from a poultry facility. And when you think about those pathogens of consequence and those pathogens that cost us money, you'll notice most of them are on this list. I think when we talk about water, most of the time we think of E. coli, or we think of fecal coliform or some other pathogen that we hear all the time. But what we don't understand is something like avian influenza, where we've had issues throughout the world, but I'll speak about the Northern Hemisphere at this point. We have had proof that every avian influenza break in our industry since the year 2000, patient zero is a contaminated water source. So we look around at all the biosecurity that we're doing on these farms, and we're doing it for a reason, but it's that one little chink in the armor, if you will, that a contaminated water source causes the outbreaks of influenza. Now, we carry it as people from farm to farm afterwards, but the reason we care so much about migration patterns and what routes these birds are taking when we're talking about migratory waterfowl is because if they're carrying influenza and land on a pond, and that pond somehow becomes the drinking water source of that farm, that's where we get our influenza break. And so we've got to look past just our normal pathogens like E. coli that we typically think of, and start thinking about Pseudomonas, start thinking about influenza, start thinking about Clostridium, because everything on the planet requires water to live. So water can then carry everything on the planet. Most people in reaction to this say, I use bleach, I'm fine, I know I'm killing everything. This is going to be the one time I talk about a specific intervention in this presentation. And the reason is because all of the pathogens that you see on the screen right now have been shown to be resistant to bleach at levels that you can run it in water. And so if you have Clostridium breaks, bleach isn't going to keep that from happening. If you've got a rota issue, if you've got a Pseudomonas issue, running bleach as your primary disinfectant is not going to keep your birds from getting that pathogen. So moving past that to the second thing that we care about, minerals, right? And what does that mean? It's stuff dissolved in water. Okay, water on its own, if you remember back, for me, I took my first chemistry class in 10th grade in high school. It's the universal solvent. And what happens is water goes through the earth and becomes groundwater. It trickles through. Then it picks up any impurities that it can dissolve along the way. And that is what actually creates the mineral profile for the water coming out of the ground. If you're dealing with surface water and you've got, runoff coming in, that water is dissolving the minerals that it comes in contact with, and then it's holding them in the water. And so the reason we care about that is because those minerals can interact with the GI tract of the bird. Those minerals can either help or hinder different processes we're doing at the farm. And to me, probably the largest issue with minerals is the operation of the watering equipment itself, right? The buildup that it creates. And then subsequently, what that means for consumption with those birds. And then, lastly, kind of how it interacts with the other nutritional or medicated water-soluble products we're adding to the water. And your mineral analysis is going to help you determine which chemistries make the most sense when we look at changing a process inside of that water, okay? So what do we typically look for? This is the sampling sheet that if you called me and said, what do I need to test for? I would send you this sheet that you see on the screen right now, okay? You'll notice, and we'll talk a little bit more about this later, what those minerals are. And you'll notice there are probably some missing on there that you would normally see on a water quality test. But the minerals that I've got listed down there, and I'm not going to go through them because you can read them yourself, those are the minerals that, number one, can have a consequence inside of that bird, and number two, are easy enough to measure that we know we can get an ROI and a better understanding of what is happening inside of that water prior to your bird getting a drink of it. And then pH, right? Why do we care about pH? pH is just a measure of hydrogen in water. That's it. The reason it's called pH is that's actually the mathematical formula of the inverse log of the amount of hydrogen in your water. Now that will be the last time I talk about math in anything past pre-algebra today. But the reason we care about pH is because that pH level of the water is going to drive processes inside of that bird, okay? It's going to drive processes inside of the water as well. pH is directly linked to how fast disinfectants work. It's directly linked to what that water can dissolve. So either holding minerals in solution or having them come out of solution if you want to take them out. And that in turn is going to improve how that bird functions, as well as how the equipment inside of your barn functions. And it's going to determine, again, which chemistries and processes make sense for you and what you're trying to get out of your water quality. But you'll notice in that footnote that it's decisions for water treatment, right? There wasn't a, do this, do that. That's because there's not a black box or a silver bullet for water treatment. If there was, this would be a much easier conversation to have, right? Buy this black box, it fixes what you need. If there was, instead of being in my glorified closet, which is why I've got this virtual background back here, I would be on a beach in the Caribbean, not worrying about COVID-19 and drinking Mai Tais in the sand, right? Because it would be easy and everybody would have to do it. But that isn't how water works. I wish that it was. But what works on one farm isn't necessarily going to be what works on your farm. It might, if your end goal is the same as the other farm, and if your starting water quality is the same on the other farm. But I see something on the order of 1,000 water samples a year, and I've never seen two that match. So obviously the most important thing for us to do to start is to take a water sample. And if you could read the small writing on the computer screen earlier, you would have read what I'm saying right here, which is we want to get that sample so that we can set that baseline and understanding what you have to start. We can engineer that specific solution and come up with a custom solution for your facility. But that's only part of it, because while we care what's coming out of the ground or coming in from your water source, what we really care about is what the birds are drinking. So we actually need to take two samples. You take one up front and you take one at the end. So one as close to the front of your facility as possible, preferably before anything happens to it. And then one as far away from that as you can get, out of the drinker. And so that means, yes, I want you to pull a nipple off of a nipple drinker and take it there. Yes, if you have bell drinkers, I want you to stick the cup into the bell and take a sample. And why? Because I want to know, and you want to know, what the birds are actually drinking, because that's all we care about. You can have great water coming in, and if it is dirty by the time it gets to the birds, it didn't matter that it came in clean. You can have terrible water coming in, and as long as it's clean when that bird drinks it, it doesn't matter how terrible it is coming in. What we want to focus on is what the birds are drinking. So that means don't flame the tip of your sample site, right? The birds aren't in there with a cigarette lighter flaming the tip of the nipple, right? They're just drinking off the nipple. Don't run it until it's cold, right? I know that these two things are different than anyone, if you've talked about water before, would typically tell you. But the birds aren't running the water till it's cold. They're getting what's out of that cup while it's there. They're getting what's coming down off the nipple or what's inside the bell drinker, right? That's what we want to focus on. And then we want to test for the right minerals and pathogens. What does that mean? Don't test for lead. Don't test for arsenic. Don't go looking for influenza. If you find those minerals or pathogens, you have a requirement to treat for it. So instead of looking for it, just don't look. And then let's build a sample that takes those, or build a treatment system that takes those into account. So make sure that you test the right way and for the right things. And like Stu was saying earlier, right? You guys are going to have this presentation if you want it. All of this is in there, so you don't need to take notes or anything like that. But we're really looking for what the birds are drinking. And then you get a water report. Okay, these are the results. It's a bunch of numbers. This is a lab that we use. As you can tell, I got this report about a week and a half ago. So that tells you when I started working on my presentation. And it's got numbers, and then it's got a little pretty graph at the bottom, and that's great, right? But we really wanted to take two samples. So now we have one from the front and one from the back. These are actually matching samples from front and back. You'll see there's a change there. So now we have those two samples. But what we don't have is what to do. What does it mean? How is some of it blue and some of it green, right? What does it really mean? Well, that's where you start laying them out side by side and making your comparisons. Now, I honestly took a different sample. This is a real sample that I got about 2 weeks ago, just to show you the differences that we see between water coming in and water was what's actually at a drinker. And you start making those comparisons because that will tell you what's happening in the barn. And you can tell just from looking at these two, there's a significant amount of shift between sample 1 and sample 2. So there's a large change inside of those water lines between what's coming out of the ground, what's actually getting to the birds. But this is where it really starts getting a little more complicated, okay? The real analysis is, what do you need as the grower, as the hatchery, as somebody that's got breeders versus broilers, right? Because if you're a broiler, you need more weight and you need better feed conversion. But if you're a breeder, you're trying to keep them on standard. We're not trying to do things to increase weight. We're trying to have more eggs, and we want them to be fertilized. If you're a layer complex, you want unfertilized eggs of a specific size, right? So what we need to do is figure out what makes you more money specifically, okay? We're not talking about cleaning the water. We're talking about setting the water up for the bird and for what it will do with it and making sure we get a return on investment. So really defining what makes you more money will help you do the analysis of the water samples that you have. So if you're looking for more weight, what do you need to have happen? You need to drive water consumption, because water consumption is going to drive feed consumption. And those two things together, if nothing else changes, you'll get a bigger bird faster, right? You need that immune system to function as little as possible, because you need all those calories to go towards building weight, not fighting disease. And you need that GI tract to function because you have to absorb the minerals that they're bringing in, whether it's through the feed or the water. They have to be bioavailable. If you're looking for feed conversion, right, you need that immune system to function as little as possible, right? And you need that GI tract to function at its peak. fewer maintenance issues, if that's what's driving your changes into water quality. You need to reduce the buildup, whether it's mineral buildup or biological buildup. You've got to keep the buildup down, because that's what's causing your drinkers to stick open and leaking all over the floor, which creates the puddle, which creates all the other issues that you see inside of a barn from that, right? Or you need to limit the growth that's clogging the nipples closed, right? So that you don't get the volume to the birds. And then you're going to have all the issues that come from water-starved birds, right? We need to make that determination. And then if you're looking for less disease or medication, you can't let them get sick, which means you have to interrupt the cycle of pathogen to host. So we got to kill that pathogen, right? So get them to drink. You can guess why I picked Canada Dry Ginger Ale for this picture. Sorry, I'm from America. It was the one thing from Canada I could put in there, okay? What do we need to do to get them to drink? We need to make that water taste good. So that means we're going to chase hydrogen sulfide and sulfur dioxide. Those are elements that make water taste and smell poor to birds. They'll drink enough to survive, but they won't drink any more than that because they think it's going to make them sick. And frankly, it will, because those are compounds that come from biological contamination. We want an acidic pH. Why? Because birds have two taste buds. They can taste sweet and bitter. Sweet in the environment is calories. Bitter in the environment is poison. So when we drop the pH below 7, we change the taste profile to taste sweeter, and those birds think that they're getting calories out of it. That's especially true for organic acids. That's little o, not big O for organic. And then we can add flavoring agents in there. Reducing immune function, we got to stop pathogens from coming in contact with them. It was very easy for me to find a picture of COVID-19 because there's like 97,000 of them on the internet. This is what it looks like. And those are the antibodies attached to it. So we want to stop that immune system from functioning. We got to keep them out of contact with the pathogen. And then peak GI tract function. What does that mean? The minerals and the vitamins and the calories that we're giving that bird through its feed, we've got to make them bioavailable. We've got to make it so they can get across that GI tract. So we need, deeper crypts, longer villi. We got to reduce the pathogen load because they're going to come in contact with the surface of that gut and take up a binding site. And then we want to put some prebiotics or make prebiotics available for the beneficial bacteria inside of that gut so that we get the benefits of what the bird is naturally going to produce or what maybe you've added in there to help the bird out. We want to increase volume. I had to put this slide in here just so I could show this picture. This is my favorite picture of all time. It is from a production facility, and that is the water supply line. And they couldn't figure out why the animals there were getting sick. And then you look at that picture and realize that's not iron buildup, that's E. coli. And so we want to keep that out of the water line. And also, water volume is solely dependent on pipe diameter. And if there are any engineers on here, you'll sit there and think, well, PV equals nRT, I can increase pressure and get more volume to the birds. You can't. Because at the bird level, we're at 12 to 18 inches inside of the standpipe, right? Which means at the bird level, that water remains constant for pressure. So if pressure remains constant, the only way to increase volume is to increase pipe diameter, and that's it. We can argue all day long if you want about it, but until you take regulators out of a poultry barn, the only way to increase volume to the actual bird is increasing pipe diameter. And then interactions with your additives. What else is going on inside of that water line? What are you mixing them with? Are you getting it to the bird in the right time, right? Depending on what you're putting in there, there are time frames that need to happen. So we need to really look at what the water is doing and interacting with those additives, right? And both of these pictures are from poultry production facilities. This is normal, right? We don't build barns in places with good water. We build houses for people there instead. And so we start seeing all these things, especially as we get some age on barns, if no one's actually looked at the water before. So how do we get from this to there? How do we really understand what we're looking for? Well, you got to look at the changes, okay? Where you see minerals that build up like manganese, like calcium, and some other ones that are on here. In just this sample, here's 3 different ways we can tell you're getting waterline buildup, okay? Biology buildup. Obviously, the coliform and the E. coli levels tell us that we have biology buildup. But even if we didn't test for those, and frankly, I'll be honest, the only reason they're on my list is for you, not for me. I don't care what your fecal coliform and E. coli numbers are. It's a cheap biological test that makes the person reading it feel better that you got a complete test done. But what I'm looking at is pH, nitrates, and sulfate. If those change because those minerals do not gas out of water lines, if they do, it's because there was biological interaction. So even if coliform and E. coli both would say non-detect, I would tell you you have biology because the sulfate levels change and the pH levels change. And that would tell me, well, you have biology, it's just not E. coli or fecal coliform. So then we really start worrying about it, right? But these are the things that tell us we've got biological buildup inside that sample. These are also the things that tell us you probably have some taste and odor issues inside of there, right? Why do you have those changes? What is that doing to the taste profile of that water? And then you look at all of the different things that can interact with the different additives. Depending on what you're putting in there, these numbers matter. They make things more or less bioavailable inside of the water line, which means that animal is either getting what you want it to get or you're keeping it from getting what you want it to get. And what that will be determined by is what you're trying to put in there and what's in your water, and you really start digging further into that. But these are the things that can cause interactions with water-soluble additives. So how do we get them to thrive instead of survive? You know, it's funny. Everybody outside of the poultry industry thinks this picture is bad. But I think this picture shows exactly how good we've gotten at making protein, right? 50 years ago, we had a 905 gram bird, right? I also sought this out because it was in metric, and I'm not very good at those. And now we've got a 4.2 kilo bird in the same amount of time, right? We've done so much in husbandry. We've done so much with crossbreeding, with nutrition, with ventilation, with lighting programs, right? Feed, light, air, water. Now's when we're really going to start looking at water because we've spent so much time on everything else that water, to me at least, kind of seems like the last frontier. So how do we keep pushing this bird, right? How do you take a Ferrari and make it go fast? Not with unleaded gas, right? You got to put racing fuel in it. So how do we start looking at water like racing fuel and get them really to thrive to their genetic potential, not just to standard? So again, we take that Canada Dry, right? We get them to drink more. How do we do that? Well, you can look at the ingredients on the Canada Dry label and see how they're doing it, right? They're putting water-free pathogens in there to start. They're adding calories with the corn syrup. They're dropping pH with the citric acid, right? They're adding that flavoring agents. You're talking about this one has real ginger in it, right? So they're adding flavoring agents into it. And that improves the function of the gut. That's why our parents, or at least mine, when I got sick, I got ginger ale and saltines, right? The low pH tightened my gut up. right? Allowed me to absorb more, took the symptoms of that illness away from me, right? The essential oils in the ginger had an effect on the lining in my GI tract. We're doing the same thing for birds. They're just not necessarily sick. We're setting them up to survive and thrive and setting them up to go faster just by giving them water that we want to give them, right? So it's when we talk about water treatment, we're really not talking that much out of the realm of making ginger ale for chickens. Reducing that immune function, you got to disinfect the water, right? That's how we get past those immune issues. We keep that pathogen from coming in contact with the bird. We do that in the number one oral input by making sure that water is pathogen free all the way to the bird, right? Not just when the water comes in, all the way to the bird. That peak GI tract function, right? We're adjusting the pH and the mineral loads. We're disinfecting the water. We're adding nutritional benefits. We're making decisions on what's going to pass through those semi-permeable membranes by what we're adding to the water or what we're taking out of the water to make everything we put into that bird more bioavailable, right? Everything goes into that crop and then goes into the GI tract. When they mix, let's make sure we get the most out of it that we can. Increasing volume to your birds. Clean your water lines and 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 clean your water lines. And maybe think about keeping the minerals from falling out of solution or make them fall out and filter them, but then clean your water lines. The single most important thing that you can do as a producer to improve water quality and improving the performance of your birds is cleaning your water lines at least between every flock. If you're a layer or a breeder producer and you've got those much longer production times, or maybe even a heavy bird, if you've got that type of bird, you can clean water lines while birds are in the house. But at the very least, clean your water lines between every flock. It matters. It matters for maintenance and headache that you have to deal with. It matters for longevity of your equipment. And most importantly, it matters for the volume at the end of a flock. You will never notice a dirty water line for the first 2 weeks, maybe even 3. But depending on how bad that buildup is, if you have birds that drag at the end of the flock and you just can't put weight on them, start looking at how much they're consuming at the end of the flock. If your water consumption is going up, up, and up, and then it plateaus out, they can't get the water. And they can't get the water because the pipe diameter determines volume. And the only way to improve pipe diameter is to clean your water lines or replace them. It is much easier and much less expensive to clean those lines between flocks, and it's not going to take you more than an hour than it is to try to replace all those drinkers. And then interactions with the additives, clean your water lines, right? Clean your water lines. All of that buildup, all of those impurities that have now concentrated inside of that water line are going to have interactions with that additive. Use a clean stock bucket, right? This picture is from a poultry barn. It's not in Canada, it's in Maryland. I hope nobody from Maryland's on here, but y'all been growing birds in Maryland for so long that you're lazy and you take the nice buckets home, okay? My company makes products in 5-gallon buckets or 20-liter buckets. None of them leave our shop looking like this, right? I've never seen a nice 5-gallon bucket on a barn. I've seen plenty of them in the back of somebody's pickup truck to take home because now they got a new bucket, right? You can flip that bucket upside down and keep it from getting dirt and dust in it. You can put a lid on it to keep mice from getting in it. I've got a picture, it's got a dead mouse in one, right? You can rinse it out when you're done. Or You can put a trash bag in there. That trash bag's clean. The bucket may be dirty, but the water going in it and what you're adding to the water will stay clean. And you can adjust that water in the stock solution to meet the needs of the additive. If you need a lower pH, use citric acid or sodium bisulfate, right? They're both cheap. Depending on what you're adding will depend on what acid you want to use and what's in your water, right? If you have high calcium levels and high buffering capacity, you're not going to be able to use citric. You're going to have to go to a sulfuric acid or some other mineral acid. If you're looking to increase it, use baking soda. I know for years this industry has said use ammonia, but ammonia is a surfactant, which means it's going to affect the outside of the molecule you're putting in there. If you use baking soda, you're going to raise the pH, but you're not going to have those surface interactions. And then if you're running a live virus vaccine or something like that, you're going to want to stabilize that with a second generation or better stabilizer. Why not just powdered milk, right? That's what I would call a first generation stabilizer, because they don't affect osmotic pressure. And osmotic pressure in water can break down live virus vaccines and other weak cell walls, depending on what you're running in there. So you want to make sure to use at least a second generation stabilizer. There's 3 or 4 generations now, whether it's got certain chemical elements in it or if it's got a color on it or something like that. But you're making all the decisions for this bird, right? Let's do right by them. Okay, they don't get to pick. They don't get to have coffee in the morning and a water in the afternoon and a soda on the way home. They get what you let come out of that drinker line. So it's up to you to make those decisions to, make it a super chicken, right? So it's important that we make those decisions the right way. And part of that is continuing to get educated, right? Water research keeps going. I do it every year. I get an R&D budget. We decide what makes sense. And then we start looking at how to best find those answers to questions that we have. New data is going to continue to improve your processes, and you need to be open to changing, right? 40 years ago, there were plenty of growers that still had troughs that were still hand watering and hand feeding, right? And then came bell drinkers. And then it was like, oh, it'll never get better than bell drinkers, but now we have nipple drinkers. It'll never get better than nipple drinkers. Now we have nipple drinkers with cups. Now we have water on demand systems instead of pressure systems, high flow systems, flush systems. Be open to changes. I know that's hard to ask. I grew up on a farm too, and I like doing things the same way I have forever. But there are times when the data just makes sense. And reach out to those resources you have, right? Dr. Ritchie's putting this on. There's webinars coming up. I'm doing one next month, right? Find those people that are subject matter experts. Talk to the sales reps that come see you. Talk to the manufacturer reps. If they can't answer your questions, don't buy their product. If they can't provide you the data that you're looking for, find someone that can, or find out if that question needs to be answered. Because if you have questions, then people like me from manufacturers want to answer them for you, right? So reach out to those people. I want to thank you. I appreciate your time. I see that we have some questions, so I'm going to go to the Q&A bar. Let's see. The first one is on chlorine dioxide or chlorine, together with the possible interactions. I would say that chlorine and chlorine dioxide are both oxidants. Those interactions are going to be very similar. Their reactions with acidifiers in water is a reduced contact time needed, okay? As far as vitamins and additives, I'll talk more about this in the next webinar. But in general, the levels that we are running those disinfectants are, whatever they are, is not high enough to have any effect on anything you are going to put in water. Next question, it's impossible to bring my pH down. Tried organic and blended acids. The advice, my advice there is to find a stronger acid. Okay. We make a couple different blends. There are 100 different acids on the market. Find one that is labeled to be run on birds and pick that one. And they exist, right? We have hydrochloric acid that's labeled to be run on birds. It'll get your pH down. I promise you. It may take a little bit of it. It may take a stronger acid, but you can turn a cup of coffee back into water if you want to, right? We just have to do the right processes. So we need to see what's inside of that water sample to keep the pH up, and then choose the right chemistries to make that work. I got a question here. Simple as lower the pH, the better. If you put a bird at a 2 pH, it will smoke every other bird that's out there that you're competing against. But pHs below 4s don't matter, because the bird and the crop is going to adjust that pH back up. And so you're just running extra acid for no reason. The sweet spot that we have seen in the industry is a pH between 6 and 6.5. That's where we get the most return on the money that we put into dropping pH. Next question is lower pH, more corrosive to equipment. Most drinker companies say that anything below 3 voids their warranty. Again, I never recommend anything in general lower than a 6.0. There's some producers that want to get into the 5s, and I find that to be okay, but typically they're spending money they don't need to. They're looking for acid to solve a problem that a different chemistry would solve. So you'll hear people talk about, I want to drop pH to 5.5. I'm an organic grower, and that's how I know we kill pathogens. Well, that's fine, but you can run chlorine dioxide at 1 part per million, labeled organic, and accomplish the same goal for 1/10 of the price, right? So again, going back, looking at your water sample, what's it telling you? What solutions make the most sense? Thinking about your business. So how do we get that ROI? Another question, running chlorine at 10 parts per million to control E. coli. Thoughts? Switch your chemistry. If you're running chlorine to kill E. coli, at least half your E. coli in there is probably chlorine resistant at this point. Look at something that's a newer technology, a more novel technology, something like chlorine dioxide or peroxide. You could probably even get to a blended organic acid to do that for you if you wanted to. My worry on chlorine levels that high is that you're at 10 parts per million to kill the E. coli, but if you have anything else in the water, you're probably running 15 to 20 parts of total chlorine, and your birds are going to back off water at that point. So you're walking the line of taste and odor versus pathogen control. And you could go to something like chlorine dioxide, which has a taste and odor control claim, and kill your pathogens for less money. And at this point, I'm proud to say, because we make a chlorine dioxide per treated gallon is cheaper than bleach now. It's not the same cost for the jug, but when you look at how much further it goes, it's a less expensive solution, or at least our brand is a less expensive solution. I don't know what cost looks like in Canada. I stay out of that. But I think you've got better ways to control that E. coli. Question on here, where can I find your products in Canada? Neogen brand. Yep, Neogen brand. We've got plenty of distributors that are up there. But I would say, talk with your veterinarian, find out where they're getting their products. Anything that has this on it, it's going to be from us. But I'm not here to try to sell you something, right? I'm here to help you make good decisions and help you make those decisions. I feel like the product piece works itself out. Let's see. I saw a question about had a water issue, invested in RO, didn't see any improvements. I really wish you would have called me first, and I don't mean that in a negative way. You heard me say I see 1,000 samples a year, and I've done this for 20 years. So I've seen 20,000 samples. In those 20,000 samples, I've found 2 that actually needed a reverse osmosis machine. My guess and my gut is that reverse osmosis doesn't fix the actual problem that you're seeing. It's probably biological based because reverse osmosis does not kill biology. In fact, they grow biology. And so if you've seen no improvement whatsoever, you probably have a pathogen issue, and you could go in there with a disinfectant and actually improve that water. But I don't know that without taking a water sample. So take a water sample, get it analyzed, send it to me if you want. My contact info is on here, right? And I'm happy to take a look at it and give you an idea. Another question, recommending baking soda in an acid alkaline waterline program. No. I don't recommend an acid alkaline waterline program because there's no data showing it works. In fact, if you come next month, I'm going to show you data that says it doesn't. When we're looking at waterline programs that are shifting pH, they're not really helping you out. What you want to do is get in there with a descaling disinfectant. I know that probably everybody on here, if you're over 35 years old, has seen the bleach, ammonia, citric acid waterline cleaning program. That program doesn't work. It doesn't get you a clean water line at the end of your cleaning. And by that, I mean, if you took a sample of that water line, you would still find biology and you would still find minerals. And so what you want to do is hit that with one product. I really like peracetic acid to clean and disinfect in one step. I'm also going to save you 3 days worth of labor if you do that. Let's see. Any other questions? Okay. Without that, again, next month, I'll be doing a presentation. I believe it's the 26th of February, if I'm not mistaken, or the 10th. Dr. Ritchie, I'll pass this back to you and you can let everybody know. But I really appreciate your time and thank you again for tuning in.
Thank you very much, Jesse. Stay safe, and we'll look forward to seeing you next month. The information will be on our website, bcpoultrysymposium.com or Canadian Poultry Consultants Limited, canadianpoultryconsultants.ca. All the best and take care, everyone. Thank you very much. Bye-bye.
Thank you all.